Chapter 6. Mensuration. Mensuration means measurement, and we are going to find out the areas of different solid figures. Now, this is a circle. This is the center of the circle. This is the radius of the circle, and this is another radius of the circle. The part of the circumference in between these two radii is the arc. Now, length of the arc L is equal to theta upon 360 into 2 pi r, where theta is the central angle of the circle. Now, if we shade this portion of the circle, it is known as the sector of the circle. That means the sector of the circle is the part of the circle enclosed by two radii of the circle and their intercepted arc. Now, area of the sector is equal to theta upon 360 into pi r square. Therefore, area of the sector is equal to r upon 2 into length of arc. That means theta upon 360 is equal to L upon 2 pi r is equal to a upon pi r square. Now, relation between the area of the sector and the length of an arc is like this. Area of the sector is equal to r upon 2 into length of arc. Now the question, find the angle subtended at the center of the circle by an arc where the radius is 5.5 meter and length of the arc is 6.05 meter. Take pi is equal to 22 upon 7. Now here r is equal to 5.5 meter and L is equal to 6.05 meter. Therefore, theta upon 360 is equal to 6.05 upon 2 into 22 upon 7 into 5.5. Therefore, theta is equal to 6.05 into 360 into 7 upon 2 into 22 into 5.5. That is equal to 63. And therefore theta is equal to 63 degrees. Next question. The given figure depicts a racing track whose left and right ends are semicircular. The distance between two inner parallel line segments is 70 meters and they are each 105 meter long. If the track is 7 meter wide, find the difference in the lengths of the inner edge and outer edge of the track. Here we have the distance between two inner parallel line segments is 70 meters and length of each parallel line is equal to 105 meter. Width of the track is 7 meters. Therefore, the distance around the track along its inner edge is equal to sum of length of inner parallel lines plus 2 semi-perimeter of inner circular ends. That is equal to 105 plus 105 plus 2 into bracket pi r. That is equal to 210 plus 2 into bracket 22 upon 7 into 35. As the diameter is 70, that is equal to 210 plus 220, that is equal to 430 meter. Now, for the outer edge, the width of the track is 7 meters and therefore the diameter of this semicircle is 70 plus 7 plus 7, that is equal to 84, and therefore the radius is 42. Therefore, the length of the outer edge is equal to 105 plus 105 plus 2 into bracket semi-perimeter of outer circular ends. That is equal to 105 plus 105 plus 2 into bracket pi r. That is equal to 210 plus 2 into 22 upon 7 into 42. That is equal to 210 plus 264. That is equal to 474. And therefore, the difference in the lengths of the inner edge and outer edge of the track is equal to 474 minus 430, that is equal to 44 meters. Now we'll see what is meant by a segment of a circle. This is the center of the circle, this is radius OP, this is radius OQ, and R is the point on the circle and theta is the central angle. If we join PQ, it is the chord of the circle. Now the shaded portion is the segment of the circle. Here, this shaded portion is the minor segment of the circle and this shaded portion is the major segment of the circle. If chord PQ is drawn passing through the center of the circle, then both the segments will be equal and in that case they are known as semicircles. Now area of segment is equal to r square into bracket pi theta upon 360 minus sin theta upon 2. Now the question, calculate the area of the shaded region where quadrilateral ABCD is a square with side 8 cm each. Take pi is equal to 3.14. First we'll find out the area of sector B-AC, that is equal to theta upon 360 into pi r square, that is equal to 90 upon 360 into 3.14 into 8 into 8, that is equal to 1 upon 4 into 3.14 into 64, that is equal to 3.14 into 16. That is equal to 50.24 centimeter square. Now we'll find out the area of the triangle BAC. Here AP is equal to BC is equal to 8 centimeter and therefore area of triangle is equal to 1 upon 2 into 8 into 8, that is equal to 32. And therefore area of the segment is equal to area of sector minus area of triangle, that is 50.24 minus 32 is equal to 18.24. Similarly, we can find out the area of this segment, it comes to same, and therefore the total area of shaded portion is equal to 18.24 into 2, that is equal to 36.48 centimeters square. Now we'll see about Euler's formula. Look here, you can see some solid shapes, that is three-dimensional shapes. These shapes are having polygonal regions only, so all these figures are called as polyhedrons, and these shapes are having curved surfaces and polygonal faces, and these are called as non-polyhedrons. Now observe these figures and these figures. All these figures are having lateral faces perpendicular to the base and they are rectangular, so they are known as prisms. And these are having lateral faces triangular and triangular faces meet at a single point. These are called as pyramids. The letter V stands for number of vertices, F stands for number of faces, and E stands for number of edges. So the Euler formula is F plus B is equal to E plus 2. It is true for any polyhedron which is convex. The question is, using Euler's formula, find V if E is 30, F is 12. If the solid figure is a prism, how many sides the base polygon has? F plus V is equal to E plus 2. Therefore 12 plus V is equal to 30 plus 2. Therefore V is equal to 32 minus 12, that is equal to 20. If the solid is a prism, then F is equal to 10. Now we'll see about surface area and volume. It is a cuboid. It is rectangular parallelopiped and it is parallelopiped. The formula is total surface area of the cuboid is equal to 2 into bracket LB plus BH plus LH, where L is the length, B is the breadth and H is the height. Vertical surface area is equal to 2 into bracket L plus B bracket complete into H. The diagonal of the cuboid is equal to under root L square plus B square plus H square. And the volume of the cuboid is equal to L into B into H. The area is represented by unit square and volume by unit cube. The question is, a fish tank is in the form of a cuboid and the external measures of that cuboid are 80 cm by 40 cm by 30 cm. The base, side faces and back face are to be covered with a colored paper. Find the area of the paper needed. Here, the total surface area of the cuboid is equal to 2 into bracket LB plus BH plus LH. That is equal to 2 into bracket 80 into 40 plus 40 into 30 plus 30 into 80. That is equal to 2 into bracket 3200 plus 1200 plus 2400. That is equal to 2 into 6800. That is equal to 13,600 centimeters square. Now the area which is not to be covered is equal to L into H plus L into B. That is equal to 80 into 30 plus 80 into 40. That is equal to 2400 plus 3200. That is equal to 5600 centimeters square. And therefore the paper required is equal to 13,600 centimeters square minus 5600 centimeters square, that is equal to 8,000 centimeters square. Now this is a right circular cylinder. This is the radius, this is the height, and the radius of the upper part is also same, that is R. Now the curved surface area of the cylinder is equal to 2 pi RH. And the total surface area of the cylinder is 2 pi R into bracket H plus R. The volume of the cylinder is pi R square H. Now the question, the radius and height of a cylinder are in the ratio 3:7 and its volume is 1584 centimeter cube. Find its radius. Let the radius be 3x and height be 7x. Now volume of cylinder V is equal to pi R square H. Therefore 1584 is equal to pi into 3x bracket square into 7x. Therefore 1584 is equal to 22 upon 7 into 9x square into 7x, that is equal to 22 into 9x cube. Therefore 1584 upon 22 into 9 is equal to x cube. Therefore 8 is equal to x cube. Therefore x is equal to 2. And therefore the radius is equal to 3x, that is equal to 3 into 2 is equal to 6 centimeter. Now this figure is right circular cone, or you can call it as a cone. This circular part is having the radius R and the perpendicular height is H. Now this is the slant height, which is L. If H and R is known, using Pythagoras theorem we can find out L, because POB is a right angle triangle. So slant height L is equal to under root H square plus R square, then curved surface area is equal to pi R L, and total surface area is equal to pi R into bracket L plus R. Volume of the cone is equal to 1 upon 3 into pi R square H. Now about the frustum of the cone. Frustum is a Latin word meaning piece cut off. If the cone is cut off by a plane parallel to the base, not passing through the vertex, two parts are formed. The first one, a cone, a part towards the vertex. and the second one is the frustum of cone, the part left over on the other side. Let h be the height, L be the slant height of the frustum, and R1 and R2 be the radii of the ends, where R1 is greater than R2 of that frustum of the cone. Therefore, slant height L of the frustum is equal to under root h square plus R1 minus R2 bracket square. The curved surface area of the frustum is equal to pi into bracket R1 plus R2 into L. Then total surface area means pi into bracket R1 plus R2 into L plus pi R1 square plus pi R2 square, and volume is equal to 1 upon 3 pi into bracket R1 square plus R2 square plus R1 into R2 bracket complete into H. Now the question: the curved surface area of the frustum of a cone is 180 square centimeter and the circumference of the circular base are 18 centimeter and 6 centimeter respectively. Find the slant height of the frustum of the cone. Here, the circumference of circular base is equal to 18 centimeter and therefore 2 pi r1 is equal to 18. Therefore, pi r1 is equal to 9. Therefore, r1 is equal to 9 upon pi. Now, the another circumference is 6 centimeter. Therefore, 2 pi r2 is equal to 6. Therefore, pi r2 is equal to 3. Therefore, r2 is equal to 3 upon pi. Now, the curved surface area of frustum is equal to pi into bracket r1 plus r2 into L. Therefore, 180 is equal to pi into bracket 9 upon pi plus 3 upon pi into L. Therefore, 180 is equal to pi into 12 upon pi into L. Therefore, 180 is equal to 12 into L. Therefore, L is equal to 180 upon 12, that is equal to 15. Therefore, the slant height of the frustum is equal to 15 centimeter. Now this is a sphere, a solid obtained by revolving a circular lamina about any of its diameter. Here the total surface area is equal to 4 pi r square and the volume of the sphere is equal to 4 upon 3 pi r cube. The sphere has only curved surface. Now this is a hemisphere. A plane passing through a center of a sphere divides the sphere into two equal parts and each part is a hemisphere. The total surface area of hemisphere is equal to 3 pi r square and the volume of hemisphere is equal to 2 upon 3 pi r cube. The curved surface area is equal to 2 pi r square. Now the question: a toy is a combination of a cylinder, hemisphere and a cone, each with radius 10 centimeter. Height of the conical part is 10 centimeter and the total height is 60 centimeter. Find the total surface area of the toy where pi is equal to 3.14 and root 2 is equal to 1.41. Here the radius of the cylinder is equal to 10 centimeter and the height of the cylinder h1 is equal to total length minus radius of hemisphere plus height of the cone, that is equal to 60 minus 10 plus 10, that is equal to 40 centimeter, and therefore the curved surface area of the cylinder is equal to 2 pi rh, that is equal to 2 into 3.14 into 10 into 40, that is equal to 2512 centimeters square. Statement 1. Now the radius of the cone is 10 centimeter and the height is 10 centimeter. Therefore, L square is equal to h square plus r square, that is equal to 10 square plus 10 square, that is 100 plus 100, that is equal to 200. Therefore, L is equal to under root 200, that is equal to under root 2 into 100, that is equal to 10 root 2 centimeter. The curved surface area of the cone is equal to pi RL, that is equal to 3.14 into 10 into 10 root 2, that is equal to 3.14 into 10 into 10 into 1.41, that is equal to 442.74 centimeter square. Statement 2. Now the radius of the hemisphere R is equal to 10 centimeter and the curved surface area is equal to 2 pi R square, that is equal to 2 into 3.14 into 10 into 10 is equal to 628 centimeter square. Statement 3. And therefore the total surface area of the toy is equal to statement 1 plus 2 plus 3, that is equal to 2512 plus 442.74 plus 628, that is equal to 3582.74 centimeter square.